The most tedious part of any roughing toolpath is getting the cutter to the bottom of a pocket. During pocket entry, the material removal rate is at its lowest, all the work is being done by the tip of the tool, and the small chips created tend to be recut as they travel up the cutter's flutes, speeding up tool wear. Depending on workpiece material and cutter geometry, entering pockets may not be possible in the first place. We already have an OptiRough toolpath created on this upright. If we turn off the rapid retract motion on the advanced toolpath display dropdown, we can see all the entry periods shaded in green. If we open backplot, we see that the toolpath doesn't start dynamic roughing from outside until after it enters 4 pockets. Because of this, the tool may be somewhat worn or even damaged before getting to the main portion of the toolpath. This behavior makes this toolpath a perfect candidate for skipping pockets. Let's make a copy of the original toolpath to test out 2 different methods of pocket avoidance. The most common method of skipping pockets requires the user to create whole fill surfaces and then select them as drive geometry. These fill surfaces are on level 3. Open the model geometry page of the first OptiRough toolpath and select the fill surfaces as additional machining geometry. After regenerating the toolpath, we can see that all the green entry motion sections have been eliminated. This method of avoiding pockets is completely reliable, but requires lots of manual user input, and as we are about to see, it leaves extra material behind. In the second OptiRough toolpath, activate the new Skip All Pockets option on the toolpath control page and regenerate. This new feature automatically avoids any areas of the part that require entry motion. Only the areas of the part reachable with from outside motion will be machined. The advantage of this is that we didn't need to manually create fill surfaces. As you can see, this new toolpath clearly enters the area that was covered by the fill surface used in the first toolpath. If we turn off level 3, we can see how much material was removed from underneath the fill surface without requiring entry motion. If we create a stock model to represent each method, we can clearly see the difference in the resulting model. By converting the stock models to a P-mesh, we can analyze each and see that the second toolpath was able to remove an additional 2 cubic inches of material. Thanks to the new Skip All Pockets option in the OptiRough toolpath, Mastercam 2021 makes it quicker and easier to achieve the exact results we expect from a roughing toolpath.